class. In today's video, we're going to talk about radical equations. And simply put, radical equations are simple equations with radicals in them. And to go about solving a radical equation, we're going to look at this process that I've listed on this side. Okay? So, the first thing you want to check for is when you're solving a radical equation is you want to make sure that you isolate the radical. Step 2 would be to remove that radical. And removing that radical, if you do not know how to do it, let's say you have a radical with the which is the square root of x. The reason why it's called the square root is because there's an index here of a 2 that you can't see. Alright? And in order to get rid of this radical, I have to raise it to whatever that index is, which is 2. That will get rid of this radical, the square root, and it will leave me with x. Consequently, if my index is a 3, as you see here, right, this would be a cube root of x. To get rid of this radical, I would hate to take the cube root of this whole thing, which will give me x. And the same thing here, and consequently, if we have whatever the index is here, I would have to raise that to that power, okay, and that will give me an x. Once we've removed the radical, the next step would be to solve for the variable. And these are the sample problems that we're working on this side so that you can see how that's being implemented. Alright, so let's get started. Let's take at the first problem. I have the square root of x equals to 4. To solve this problem, once again I said you have to isolate the radical on one side of the equation. However, this radical is already isolated, so you don't have to do anything. So let's move on to step 2, where we have to remove the radical. Since this is a square root of x, right, to get rid of it, we have to raise it to the power of 2. Since there's a 2 over here that we can't see, we have to raise it to the power of 2. But whatever I do on this side of the equation, I also have to do on this side of the equation. So I would also have to raise this 4 to the power of 2. So this, raising this square root of x raised to the power of 2 will give me a value of x. Okay? It will just basically get rid of my radical, and on this side of the equation I will be left with 4 squared, which is 16. So that is my answer for that first example. Okay? Let me go ahead and erase this one, and let's move on to the next example. And we'll just go ahead and move to the next example here. And let me write with a different ink pen because this one makes a mess whenever I try to erase it. Let's look at example number 2. This one is 6 equals the square root of a fraction, which is x over 6. Once again, to solve this problem, okay, we look at the process that we have here, and step 1 is to isolate the radical. And we're going to try to isolate this radical, but this radical is already isolated. There's nothing else being multiplied or added to this radical. So it's already isolated. So we're going to move on to step 2, where we have to remove the radical. Since this is a square root, we have to raise this entire radical to the power of 2. Alright? But whatever I do on this side of the equation, I must do on this side of the equation. So basically, I'm also raising this 6 to the power of 2. On this side, this leaves me with 36 equals x over 6. Alright? Now, what we have here is we have a fraction on one side, and basically the easiest way to solve this is to multiply both sides by 6, which is the denominator, to give us our answer for x. So if I have a fraction on this side, to get rid of my denominator, I have to multiply both sides by 6. Okay? And this will cancel, this will give us x is equals to, I believe it's 216. Okay, I hope it is. Yes. Alright? So this is our answer for this problem. Alright, so let's move on to example number 3. We'll go ahead and erase this. Should have a mat or something. Anyway, example number 3 is the square root of x minus 4 equals to 3. Okay. And in here, what we have is a radical and there's a binomial under it. So what we have to do once again is, let's look to see the process. We're going to have to isolate the radical, which it already is isolated on one side of the equation. And then we're going to have to remove the radical. So to remove this radical, once again, is just the square root. So to get rid of this radical, I would just raise this to the second power. But whatever I do on this side of the equation, I have to do on this side of the equation. So I'm going to have to raise that 3 to the second power. What I'm left with on this side, on the left-hand side, is going to be x minus 4. And on the right-hand side, I'm going to be left with 9. And at this point, we're just going to have to solve for the variable. So let's go ahead and solve for x. Okay. To do that, I'm going to add 4 to both sides. And I'm going to be left with x. This cancels, equals 13. And that is our answer for this particular problem. Okay. The next step, actually the next example, let's go ahead and do that now. I'm going to erase this. And we're almost done. In the next example, we've got negative 8 plus the square root of 5x minus 5, okay, equals a negative 3. So let's go ahead and solve this problem. Okay? So once again, we're going to look at this process to solve this problem. First of all, we want to isolate the radical. So in this particular example, this radical is not by itself on this side of the equation. So we have to do that. We have to get this radical by itself on this side of the equation. To do that, I want to get rid of this 8 that's being added to it. So I'm going to add 8 to both sides since that's a negative 8. I'm going to add 8 to this side. So this gets rid of my 8, and I'm left with the square root of 5x minus 5 equals negative 3 plus 8 is just 5. Alright, so now what we've done is we've isolated the radical on one side of the equation. The next step is to remove the radical. So let's go ahead and do that. Since this radical is the square root, alright, we basically raise it to the second power to get rid of this square root. Whatever I do on this side, once again, I have to do on this side of the equation, so I have to raise this 5 to the second power. And it leaves me with, on the right-hand side, with 25, and on the left-hand side, 5x minus 5. So at this point, we can just solve for x. Let's go ahead and do that. So we're going to add 5 to both sides. Okay, this is 30 on this side. Over here, this cancels. I'm left with 5x on this side. And I'm solving for x. I'm going to divide both sides by 5, which this cancels. X is equals to 6. And there you have your answer for this particular example. If you have any questions, once again, you can just rewind on this video and pause it wherever it's step you got stuck at and just go from there. Anyway, let's look at our last example. I'll go ahead and erase the rest of this. And we'll get to our last example. We're almost there. In our last example, we've got 6 times 5x under the radical equals to 30. Now, once again, to look at this problem, this is basically a multiplication on the left-hand side equals to 30. So the process is still the same. We want to isolate the radical, okay, if it's not by itself. And in this case, this radical is not by itself. It's being multiplied by 6. So the first step is to try to get rid of the 6. To do that, since it's being multiplied, we're going to divide this by 6 to get rid of the 6, but whatever we do on this side, we must do on the other side of the equation also. Let's go ahead and do that. And on the right-hand side, I'm left with 5. 30 divided by 6 is 5. This is canceled here. And on this side, I'm left with 5x under the square root. So we've now isolated the radical on the left-hand side. Okay? Now let's go ahead and remove that radical. To remove this radical, okay, since it is a square root, okay, I'm just going to raise it to the second power. And whatever I do on this side, I must do on this side. So I'm going to raise this to the second power. Okay? So on the right hand side, I'm going to be left with 25. And on the left hand side, I'm going to be left with 5x. Now that we have removed the radical, let's go ahead and solve for the variable that was under the radical that is not anymore. So at this point, we're going to isolate this x. And to do that, we're just going to divide both sides by 5. Alright? That cancels, and we're left with x is equals to 5. Alright? So this is our answer here.